This video has the solutions for derivatives of functions in graph table form. This is the second one, number 2. I guess you can tell by looking at those graphs, can't you? So let's see, what would the, I guess it's easier maybe to first draw the derivative, since this is a derivative itself, the second derivative, just drawing the derivative there. So I'm first going to look for maximums and minimums here. Those would be zeros in the derivative of that. It looks like it peaks, like the steepest it ever gets here is somewhere in the middle, and then so it looks like it has negative slopes, something like that. And if that looks like a cubic to you, it should make sense that the derivative is a square function. Now going backwards, so let's see what we have here. I'm going to look at the zeros of this to get back to the original function. So here we have a place where the derivative is 0. That means I have a maximum or a minimum. And we're going from positive slopes to negative slopes, from increasing to decreasing. So that means I have a maximum. So right where that is, there would be a maximum. And then here, opposite, I'm going from decreasing to increasing. That's a minimum. And then here, going from increasing to decreasing, that's another maximum. And then you can follow the slopes, what they're doing through there, and see that we have something like this. And that should make sense also because this looks like a 4th degree polynomial, perhaps. Derivative of that would be 3rd degree. Remember, there's another video also of derivative sketching practice, if you would like to check that out. So here, if this is my derivative graph, and the derivative of that, looks like I have slopes over here that are positive but barely, close to 0, and then I'm increasing slopes are getting bigger, and it looks like they, well, let's go ahead and put this in. So there's a place where the slope is 0, right? And somewhere in between here and here, the slope maxes out, right? And then on the other side, now my slopes go down toward, they're going down towards 0, but they're decreasing, getting closer and closer to 0. And somewhere in the middle here, I have my steepest negative slope. So it looks like I have something that looks like something like that. Going backwards. So what if this is the picture of the slopes? So I have a function here that's always increasing. Notice here, there are no places where it crosses the axis. So I don't have any maximums and minimums. This is a function that's always increasing. It reaches a peak of increasing, like the steepest it ever gets here, and here it's increasing but only just, right? The values of this, which would be the slopes of this, are positive. So I'm increasing but only just, and then coming through here, and then coming through here again. So something like that. Maybe like inverse tangent function or who knows what, something like that. All right, those are worth thinking deeply about. It's very important to understand that and know what's going on there. All right, number 3, some calculator work. So I'm going to go ahead and put that function into my calculator, sine of e to the x. And I'm sorry I don't have the math print one, so this is going to be the for the TI-83 folks. You folks who have math print, you have a fancier version of this, right? Sine of e to the x. And the window -2, 2 for both x and y. -2, 2. -2, 2, and just make sure that I'm in radian mode, and go ahead and graph it. Okay, so I'll sketch my little graph here. Looks like it comes in, and then something like that. my f function. Use your calculator to create the graph of f prime and sketch that below. So remember the way we do that. To y2, I'm going to do math 8. That brings up my n deriv, or maybe your fancy math print thing. The function is from my y variables, y1, comma x, comma x. And I'll take the calculator a minute to do that. Yeah, it's pretty close to the function there for a while. All right, so looks like something like that. Okay. Find the equation for the tangent line to f of x at x equals 1. Sorry, x equals negative 1. Okay, to do that I need the point and a slope. So the point, I need a value for, which one is it doing, I wonder? Let's see what it is. So negative 1, so that's y1. And then if you see, I'm scrolling down here, that gives me the derivative. So I can do both of them. So y1, that's the actual function. So my point is negative 1, 0.360. That's rounded correctly to 3 decimal places. And my slope, by scrolling here, I can change which function it's giving me a value of. So the value of the slope there is 0.343. So my tangent line is y minus 0.360 is equal to 0.343 times x plus 1. And then for x equals 1, my point is, I'm looking up here to make sure I have y1 here. My point is 0.411, rounded correctly to 3 decimal places. My slope is negative 2.478. So y minus 0.411 is equal to negative 2.478 times x minus 1. There's me tangent lines. All right. Number 4. So we've got a graph here. This is a graph of a derivative. Where is f of x increasing and where is it decreasing? Well, if this is the derivative, it's increasing wherever it's positive, wherever it's above here. So that would be increasing from 1 to 5. Or you could say on the interval 1, 5. And it's decreasing, looks like everywhere else. So decreasing, I'm going to go ahead and assume that this is a parabola and it just keeps going. So negative infinity to 1 and from 5 to infinity. Where does f of x have a maximum or a minimum? A maximum happens when it goes from increasing to decreasing, from increasing positive slopes to decreasing. So that happens at x equals 5. It doesn't happen at x equals 5 comma 0, because 5 comma 0, that's a point on the derivative function, but it's not a point on the f function. So the best we can say is where it has a maximum. It's at x equals 5. What is the maximum? I don't know. I can't know that from this graph. Where does it have a minimum? At x equals 1, because here it goes from decreasing, negative slopes, to increasing, positive slopes. And then down here, our table of values. What's the meaning of the slope here? Well, this is a position time data, so the slope would be rise over 1. It would be position over time, change in position over change in time, dp dt, which is velocity. Right? Not speed, it's velocity, because it could be negative. And what would the units be? The units would be meters per second. Units of rise over units of run. Average slope from time 0 to 30. So let's see, average slope, I've got position 20, that's my final position, minus position 20, so it looks like it's going to be 0 over the 30-second interval, so it's 0 meters per second. What does this number mean? Well, it means the average velocity was 0 meters per second, but you could also say that it starts and ends in the same place. You can't have an average velocity of 0 in any other way than that. Create a table of slopes, a derivative. We talked about how to do that. So let's see. One, two, three, four, five, six, 7, 8, 9. So let's see if I can divide this up successfully to 9. That's pretty good. So this is going to be my times 0, 4, 5, 8, 9, 13, 20, 25, and 30. And here, these are going to be my velocities. I'm going to call it velocity because that's what the slope is, right? So here, for the first one, I don't have a point on this side, so I just have to use these two. So it looks like I have negative 7 over 4. For 4, I use the 2 on either side, so that's negative 8, right? Starting 12 minus 20, minus 0, so negative 8 over 5. And then for 5, I use the 2 on either side, so that's positive 10. I'm going up 10, so that's 10 over 4, positive 2.5. To get at 8, looks like I go up 13 over 4, so that's 3.25. For 9, go up 7 over 5. So that's 1.4. I hope I'm not making any mistakes here. Sorry if I am. You can catch them, I'm sure. Here, on either side, I've got 5 over 11. What is that, like 0.44, I think? For 20, it looks like I'm going down 16 over 12. Negative 1.33. 25 going down 10 and 10, so that's just negative 1. And here for the last one, I have to use those two, so it looks like I'm going up 6 over 5. So I think those are right. Okay, so those are the velocity values. Where's the speed the greatest? Where's the speed the greatest? So that means the absolute value. If the biggest number was a negative big number, then we would use that. But it looks like it's at 8. Somewhere around there. Right, that's where it went up the most. So somewhere around 8. Remember, these are only approximations, so we don't know that it's the fastest exactly at 8 seconds, but somewhere around there, somewhere between time 5 and time 9, probably. All right.